What can room temperature superconductors do for devices? Imagine a world where electricity flows effortlessly through wires, machines run faster without wasting energy, and transportation becomes smoother and more efficient. That's the promise of room temperature superconductors. These materials can conduct electricity with zero resistance at normal atmospheric conditions, meaning no cooling needed. If scientists can create stable versions, it could change everything we use daily. Right now, many devices relying on superconductors that need extremely cold temperatures to work. For example, magnetic resonance imaging machines in hospitals use superconducting magnets cooled with liquid helium, which is expensive and hard to maintain. With room temperature superconductors, these machines could become lighter, cheaper, and portable. This would make advanced medical imaging accessible in more places around the world. In transportation, magnetic levitation trains could become common. These trains float above tracks using superconducting magnets, reducing friction and allowing for speeds much faster than traditional trains. Without the need for costly cooling systems, these trains could run more frequently and at lower costs, transforming how we travel long distances. Power grids would also benefit greatly. Currently, a lot of electricity gets lost as heat when transmitted over long distances. Superconductors could eliminate this loss, making power delivery more efficient. This means lower electricity bills and less environmental impact from wasted energy. It could even help integrate renewable energy sources like solar and wind more effectively into existing grids. In the world of computers, room temperature superconductors could make data processing faster and more energy efficient. Quantum computers, which need to be cooled near absolute zero, might become easier to build and maintain. For regular computers, superconducting connections could speed up data transfer between chips, reducing lag and power consumption. Data centers, which consume huge amounts of energy, could operate more sustainably with superconducting technology. Advanced motors used in electric vehicles and industrial machines could also see improvements. These motors would operate with minimal energy loss, making vehicles more efficient and reducing charging times. Particle accelerators used in scientific research could become more powerful and less costly to run. Electromagnets for medical imaging or research could be made stronger without the cooling constraints that currently limit their size and strength. In electronics, new transistor designs made with room temperature superconductors could operate at lower voltages, making devices safer and more energy efficient. Wireless communication systems could become faster and more reliable, with less power needed to send signals across long distances. The challenge is that scientists do not yet fully understand how to make these materials stable at normal conditions. They are testing many different combinations of elements like graphene and scandium, but no one has succeeded in creating a truly reliable, stable superconductor at room temperature and atmospheric pressure. If they do, the impact will be enormous. We could see entirely new kinds of devices, faster computers, better energy storage, and smarter transportation. The potential is huge, and many researchers have been working on this puzzle for over 30 years. It's like trying to find a secret recipe that could unlock a new era of technology.